Hello everyone. Now that we are done with all of the feature selection techniques which are considered under filtered method, now the time comes when we move to the wrapper method. And in the wrapper method, the first technique which we're going to learn about is forward selection. Let me show you how it works. So let's say you have this data set, right, with one independent, which is none other than lone status, the one which you see with thick border, and then remaining five independent features. So with this, as usual, whenever we are building the model, we split the data into part. One is target and the independent feature. So here comes the target feature. Now what we're gonna do is, out of the remaining not remaining, out of all the five independent features, we're gonna pick each feature one by one, train the model, take the note of accuracy or any report, whatever the scoring technique you want to use. Here we are going to use scoring, sorry, accuracy, and take a note of that and then proceed further. Let me show you step by step. So here in the center you see this is our target feature. Now out of the independent feature I'm going to pick one, let's say young, right, and train the model with this young feature and calculate the accuracy. Take a note of that. So for young we are getting the accuracy A3. We're gonna then in the next iteration or in the next training we're gonna remove this young and train the model with next feature, which is male. Now over here you see we are left with 3 and here we have the male. We are going to train our feature with this particular feature. We are going to train our model with this particular feature and take note of accuracy, which is A1. We're going to repeat the same thing with all the remaining features one by one and take note of the accuracy for each of the training. So this is what we get, the one which you can see at the right hand side. Now have a look, out of all these five features, which one is having the best accuracy? None other than this, which is non-graduate. Means there is a feature which is named as non-graduate, which simply tells whether the applicant is graduated or non-graduated. If it is 0, means it is non-graduated. If it is 1, sorry, if it is 1, that means it is non-graduated. If it is 0, then it is graduated. Okay, so this is how the data is, and this feature is performing the best. Now in the next iteration, what gonna happen is that best feature we are going to keep static, right? We are not going to get rid of that. We are going to keep that fixed, and along with that, out of the remaining 4 features we are going to use one by one each of them and see in combination with non-graduate how each of these features are performing and which pair gives us the best accuracy. So let's try that. So first of all, again we are going to, with non-graduate we are going to use young and train the model, take the note of accuracy. So this is what we get, B4, right? Next, again we are going to do the same thing with next feature, which is male. So this time we are training the model with non-graduate, of course, which was there, and male. So with non-graduate and male we are training the model, finding the accuracy, taking note of that. Same thing we're gonna do with the remaining 2 features again and take the note of the accuracy, so which we get B1 and B2. So altogether if you see, the feature which is performing the best is non-graduate and young, right? So that's the best pair of feature which we found in the next in the second iteration. This process continues till the point from where we start seeing the decline in accuracy, right? There will be an optimal point. After that the accuracy will start declining. So what will happen is, in next iteration you would have this pair fix, and out of the remaining 3 features one by one you will try them. So in that iteration you will get 3 best feature, then again in the next one you will get 4 best feature. You would require to continue that till the point after which the accuracy starts declining with the set of features, and the point where it starts decline, that's the optimal point, and that is where you get the best set of feature for your model to perform best, right? Now let me show you this thing in Python. How would you implement this? So here in Python, let's say simply import pandas as pd and then import numpy as np from sklearn dot linear. It is auto completing, so let's just give it a few seconds to complete it automatically. So out of the linear model we'll be picking the logistic regression to train our model. Okay, linear model, import logistic regression, and then from sklearn dot model selection import train test split. All right, there would be one more library which we would require, which is from ml extend dot feature selection import sequential selector. Now in case if you don't have this particular module already installed, so what you're going to do is take this, and over here let me first import this all, and after this what you're going to do is you can simply say pip install this and just hit control enter. It will be installed. Okay, so because it is already installed in my machine, I'm not going to install it. Okay, now after that I need to import the data, which I'm going to say pd dot read excel, and inside this I have this path already available over here, so I'm going to take this one. I'll just copy paste this in order to save the time. All right, we got this. Is that all right? Yes. And after that I'm going to see df. Why is that so? Oops, sorry, this was something not accurate here. So this is what we got. Now out of this what we need to do is, you see this id variable is not needed, and diagnosis variable is something which requires to be binary. Okay, so let's just get rid of this id variable. Df underscore new equals to df dot drop, and inside that I'm going to say id access equals to 1, and let's just check df underscore new dot head. I think that is gone, right? Now let's do the next thing. In next step we need to convert this into binary. Okay, so for that what I'm going to do is df underscore new, and inside that I'm going to create another variable which is called diagnosis. Let me paste that same name from here till this, no, not till this, but just right over here, and here I'm going to use np.where, and inside that I'm going to say if this thing equals to m, then say 1, else say 0. All right, so this is what I'm going to do, and let's just see how it works. Dot head, bingo, I think it is done. Now let's just quickly check the shape of the data. Alright, df dot, first of all let me check if it has any null value. Is null dot sum. Let's see how it works. Alright, over here I need to use this one. So there isn't any feature which is null. Now you see how many features these are. Let's just check that out. Dot shape. So if you see, there are 39 features, which is quite huge to train a model, right? What I'm trying to get is I'm trying to find the top 5 features which will help me to build a model which performs the best. That's exactly what I'm going to achieve over here. So for that, I'm going to say feature selector. I would just create another instance. Let's say feature selector, and over here let's just say sequential selector. Inside that, so there are many parameters which we require to specify over here. So first of all, estimator we will require to specify, then number of features, how many features we want, then whether forward selection, floating, and verbose and scoring, and this CV. These many features we can start with. Okay, let's just start with these many features. So instead of estimator, why didn't it took. Okay, so instead of estimator, I'm going to say logistic regression, because that's what my estimator is, which I'm going to be using over here. Okay, and then after that, these are the sets which I would require to use. Now don't worry, I'll explain you what exactly these all mean. So what you see over here is k features, means how many features we want to select. So like I said, I want to select the top 5 performing best. Okay, top 5 best performing features. So that's what I wrote over here. I want to use forward selection method. So forward equals to true. Floating equals to, I'm going to keep false. Verbose. Verbose is nothing but it gives you the detail of, I mean, by the time when your model is training and it is doing the selection, it will show you the detail. I mean, which iteration is it running, how is it performing, etc. Let me show you. So the more number you specify over here, the more details you will get. So I'm going to put 4 over here. Then in accuracy, which method you want to use, sorry, for scoring, which technique, which scoring technique you want to use. So like I said, I would be using accuracy over here, and this is nothing but the cross validation. So 5 cross validation I want to perform over here, so that's why I have 5. Now next thing which I'm going to do is fit, and inside that, oops, I made a mistake before this. Before we start doing this, we need to do a train test split. Train test split, and inside this, we don't need to waste time in writing this in text manually. We can simply do shift tab, and then we will come over here, and you can copy this and then just paste it over here. Yeah, so this is done, and this we selected. This test size, it is 33%. I will just make it 20%. Test size I'm going to keep 20%. Random state 42, we can live with it. That's not a big thing. Okay, okay, now over here, this x, instead of x, what exactly that we want to use, we want to use the whole data set except the target feature. So df new dot drop, and target feature was diagnosis, right? So let me just use this one, diagnosis. Access equals to, x is equals to 1, right? So what I'm going to what I'm trying to say is, in x, use this data set which is set of independent features. Now in place of y, what I'm going to do is, I'll require to keep only this feature, which is none other than just target feature, which is diagnosis. All right, I think it is done. Now let's just see, for example, dot head. Yeah, we are pretty good. And in y train, what is it that we got? We should have one feature only. Yeah, we are pretty much sorted, right? And now over here, I'm going to use x train. Let it complete automatically, and then we will be x train, and then I'm going to use y train. And now the time comes, we should hit enter and see the magic. All right. So like you can see, what it has done is, it has selected the five set of features, right? Okay, set of 5 features, that's what I want to say over here, right? And over here, it is trying each of the features one by one in combination, and then it is giving you the accuracy also, right? So with first feature, it is giving 91%. With second feature, it is giving 94, right? That's how it is increasing. Fourth feature, and after that it is giving you lots of warning messages or etc, lots of other information. And this is the feature of, this is 5 out of 5. With all of the feature, it is giving 95, I mean 95.6% of the accuracy, and over here we have 95. So more or less both of these two are same. Now this is where it has given us, it has trained the model, and it has concluded that which set of feature we should be using. I mean, what is the best 5 features, right? So how do you know that? So now this is done. Here it is just giving you the numeric information, but how do you know which set of features you require to use? So for that, let's take this instance over here and say dot, and over here feature names. You see over here, this one, feature names. Let's just, oops, not this one, feature, let's just feature selector is here. What exactly? Feature groups. Oops, not this one. Oh, no. Let me just tell you this. I'm just oh, oh. Fixed features. I think this is what it is. Card. Why I'm using. What we are looking for is key feature names. Okay, so these are the 5 features which we require to be using. So you see, these are the 5 features. So radius, mean, this, these are the 5 features which we require to use, which will perform the best. Now there is one more thing. What you can do is, this is the 5 features. You can also bring some sort of flexibility. For example, I want to say to this particular selector method that give me minimum 5 features and a maximum of 10 features. In between that, give me what is the best set of the features, right? uh, I have 31 in total. Now out of 31, I want model to select uh, some set of features between 5 to 10, right? I want to leave it to the model only. So for that, what I can do is I can provide a tuple of that, so 5 to 10. Now let's just run this. Oops, this seemed okay. It require a comma over here. Now let it just run, and let's see how many features it is going to give us. So at first it is giving 91, then at second feature it is giving 92, third feature 95, fourth feature 95.6, and let's go down. Fourth feature, and where is fifth feature, man? Let's get going. So what you should do in beginning is you should put the warning. You should ignore the warning. You should put something which ignores the warning. Okay, I just made a mistake. I didn't put that particular line, and that's the reason I have to go through all these warning messages. It doesn't make sense. Let me come down over here. All right, so at 10th, with all of the 10 features, it is saying 96% of the accuracy. Now in between somewhere, let me do one thing. Let me just put the let me just ignore the warning first over here. Import warning. Done. Let me run this again. Again, with first feature this much of the accuracy, second feature 94.2, third feature 95.16, fourth feature 95.6. Come on, with fifth feature 95.6, similar one. Exactly the same. On sixth feature also the same accuracy, right? On seventh feature also you see the same accuracy. So now what you observe is, with at fifth feature it has, I mean, after fifth feature it is giving us the similar accuracy, right? On eighth feature it has increased slightly. On 10th feature it has increased more. Now let's see what is the best set of feature it is giving us. So 1 2 3 4 5 6 7 8 9 10, all 10 features it is saying that those are the best. Okay, I mean, this is how you can keep on trying. You if you want, you can put 20 over here, and then you can again try what is happening. Okay, so let's just see what happens over here. It's kind of interesting. That's why I'm just recording everything. I know the video is turning out to be a little lengthy, but let's just see what is it that we're gonna get. Whether it is going to tell us that all the 20 features are useful, or it is just going to tell us that use some specific set out of those 20. So with fifth, this is what we are getting. With sixth features, with six feature, this is the accuracy which we got. With seven feature, this is what we got. Let us just calculate. God, we have given too much of the load. Let's just see. On eighth feature, it is giving 90. 5.8 again. On 9 feature, with 9 feature also it's the same accuracy with 10 feature like we observed previously. Now let's see what happens on 11 with 11 feature. With 11 feature it is giving us 95.8. So you see it has started to decline after 10th feature. It has started to decline again. Now I'm anticipating that at the end it will give us again this 10 I mean this set of the features again. It has increased over here. While it is training, I'm going to take a screenshot of this so that we could see what is the next set of features it is going to give us, right? I've just taken the screenshot of this part. Now on 17th feature, with 17 feature, it is giving us this much of the accuracy. 18th feature, again the same accuracy. On 20th feature, again the same accuracy. Let's see what is it that we are going to get over here. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. Okay, so we said give us any number of feature between 5 to 20 and it is giving us 15. It is saying that these are the 15 features we should try uh, in our model building. So well, this is how you can perform the forward feature selection to find the best fit of the features for your model training. If you want, you can put the range of directly 5 to 31, and out of that you can get the most best performing feature. All right, I hope this was easy for you to understand and interesting as well. Just in case of any doubt, put that into the comment section. I'll definitely try to respond to that. Until then, happy learning. Wish you very all the best.